Okay, so in this example, we've got MgSO₄ with a given amount of H2O, and we've effectively got its mass having been determined as 13.21 grams, and we need to work out what the coefficient was with next to H2O. Like, what's the relative number of moles effectively of the H2O in this equation relative to the mole per mole of MgSO₄. We've been given the mass of the hydrated sample, the mass of the anhydrous sample, so we need to use that to work out the value of x, right? So the first thing I'm going to do is I'm going to try and work out the number of moles of the MgSO₄. That's going to enable me to have at least a comparison point to compare it with the number of moles of the H2O, right? So for MgSO₄, if we say that the number of moles is equal to the mass divided by the molar mass, right? So in this specific case, this is the number of moles of MgSO₄ is the mass, right? So in this is the hydrated mass. So this is like the MgSO₄ and with the H2O. So that's not going to be the mass we're going to use. We're going to use the anhydrous mass, right? So it's going to be equal to 6.01 divided by the molar mass of MgSO₄. So we don't have that yet, but we've got the formula, right? MgSO₄, so we can kind of work that out. So if I say Mr of MgSO₄, that's going to be effectively be what 24.3. So we have that here as well. So 24.3 plus for sulfur, which is going to be 32.1, and plus for O4, right? So we're going to be plus 16 times 4, right? So if you work that out, that's going to give you the molar mass of the MgSO₄, right? Which is going to be 120.4. Okay. So in this case, it's going to be 6.01 divided by 120.4, right? And that's going to be equal to 0.04917, and that's going to be in moles, right? And that's effectively to five significant figures. Now we've got this value, but what we also need is the number of moles of the H2O, which we haven't worked out yet. But in order to work that out, we need the mass of H2O. We've got the hydrated mass of the hydrated sample, but what we don't have is this is the mass of the anhydrous sample. So we don't actually have the mass of the H2O just given in the question. So we need to use some basic arithmetic to figure that out. So, and how we do that? Well, if we subtract from the hydrated sample mass the anhydrous sample mass, obviously what's left is going to be the mass of the H2O, right? So you can do 13.21 minus 6.01, right? And that's going to give us effectively what we're looking for. So when you do that, then you're going to get 7.2, right? 7.2 grams. And so that's the mass of our H2O. And so in this case, using this same equation, we can say that the number of moles of H2O, right, is going to be equal to, so it's going to be the mass divided by the molar mass. So it's going to be 7.2 divided by the molar mass. So the molar mass would be, if you go back to the periodic table, it's going to be H2O, right? So it's going to be 1 times 2, right? 1 times 2 plus 16, right? Which is going to give us 18, right? And that's going to be in grams per mole, right? So that as well. The other one was also going to be was grams per mole. So we just add that there. Okay. Yeah, there's something missing from here. Grams per mole. So it's to the power of -1. Okay. So that's going to be divided by 18. And that's going to give us a number of moles of 0.4. Okay, 0.4 moles. Right? And looking at the formula, we can see that on the left-hand side, we've got the magnesium sulfate. On the right-hand side, we've got the H2O. So I'm going to put the magnesium sulfate moles on the left-hand side when I'm setting up this kind of molar comparison, right? So what I'm going to do is just set up a comparison whereby we've got the number of moles of MgSO₄ compared as a ratio with the number of moles of H2O, right? Okay, and that's effectively going to be 0.049917 as ratio with 0.4. Okay, so and then one of the things to bear in mind here is that, as you can see, the coefficient, we can infer that the coefficient next to the MgSO₄ is 1, right? So we do want to get this left hand side to be 1, so that we can say, well, for every 1 mole of MgSO₄, this is the number of moles of H2O, and then we can kind of figure out what the value of X is going to be, right? So divide this side by 0.049917, right? Because if you divide something by itself, you're going to get 1, right? So that's going to give you 1, but because we're dividing the left hand side by this, what you do to the left hand side, you also need to do to the right hand side. And so that's what I'm going to do. I'm going to also divide the right hand side by that value. So divide that by 0.049917. Okay, and that is going to give me, well, you've got 1 on this side. That's going to give me 8.0133. Okay, now what I want on both sides is integer values, right? So we've got 1 on this side. So what I can effectively say, if we round the 8.0133 to the closest integer value, is that this is effectively 1 ratio of in a ratio of approximately 8, right? So approximately 8, and therefore we can say that X is equal to 8, right? And if X is equal to 8, then we can say that the formula is actually MgSO₄ dot 8 H2O. Okay, and so this here, we're going to have an 8. Okay, right, and yeah, so yeah, that's how you'd approach that.